going to look at symmetric groups. So we're going to look at groups similar to what you they're permutation groups, meaning that they permute things, which basically means all you're doing is rearranging stuff. If you have 1, 2, and 3, right, you might move 1 there and 2 there, or you might move 1 there and 2 there and 3 there. So you're just shuffling stuff around, in other words, in groups. So a permutation is one non-two function from a set to itself. So we're dealing with functions, as functions the whole time. So sets of permutations can. Permutation group is a set of permutation that forms a group under. So let's take a look at this. The symmetric group is the group of all permutations of n letters. So you have n things, 1, 2, n. You measure them on placemats, and then you can just swap them around so that in the end, every placemat has exactly one number on top of it, and every number is on exactly one placemat. So they're going to be n factorial things. Why? If I have 1, 2, 3, 4, when I permute things, I have 4 options I could go there. It could be the 1, 2, 3, or 4. There are 3 options, anything that wasn't here can go there, so there are 3 options. Here I have 2 options, anything that wasn't there can go there, and 1. So I can multiply these together to get 4 factorial. So you may have us 4. These are all permutations. This is cycle notation. And cycle notation, in case you haven't seen this before, 1, 2 means you just take those and swap it. So 1, 2 maps 1, 2, 3, 4 to 2, 1, 3, 4. 1, 3, 2, 4 maps 1, 2, 3, 4 down to here are placemats. This map says 1 goes to 3 and 3 goes to 1. So 1 goes to 3 and 3 goes to 1. This says 2 goes to 4, 4 goes to 2. So it ends up like that. And finally, this says that 1 goes to 3, so 1 is going to go to 3. 3 goes to 4. That's what this part says. So 3 goes to 4. 4 goes to 2. So 4 goes to 2. And then 2 goes back to 1. So that's what these functions. And this is called cycle notation. Writing them, 1, 2, 3 can be written as 2, 3, 1 and 3, 1, 2, because they all just take 1, 2, 3. Where does 1 go? Here this says 1 goes to 2. Here it says 1 goes to 2. Here it says 1 goes to 2. So that's where 1 ends up. What happens to 2? 2 goes to 3. 2 goes to 3. 2 goes to 3. What happens to 3? 3 goes to 1. 3 goes to 1. 3 goes to 1. But notice that 2, 1, 3 won't work. 2, 1, 3 says that 1 goes to 3, and you can already see that these are different. So that one's different. So you can just you can change the order and start with the 1 or the 2 or the 3. Here you start with a 1, here you start with a 2, here you start with a 3. But you can't change the order that they come in, because this goes 1 and then 3 and then 2. So that's a different permutation. All right. So when I do this, because I read from left to right, that's how I read my permutations. Like other famous texts like Galileans often go from right to left. They have a good reason for that. It's not good enough for me, though. They like it because they like functions. Right? If you have f of g of x, this says first apply g, then applies f. So this is first and second. Now, that's how most textbooks do it. I think it's kind of silly. I think if you have f composed with g, you should do f first, because we read from left to right, and g second, because we read from left to right. So that's the way I'm going to be doing it. If your textbook does it right to left, you're going to have to do some translation, but it all works out just fine. Neither way is right, neither way is wrong. They're both right, as long as you're consistent. Right to left. So if I want to multiply these two together, so first of all, I look at this, and I say, hey, what m's the 1? 1 goes to 3. So what happens to 1? 1 is going to go to 3, and then what happens to 3 over here? So 1 goes to 3 by this one, and then 3 goes to 4. So 1 ultimately goes to 4. What happens to 4? For this one, 4 goes to 9. Here, 9 stays put. What happens to 9? Over here, 9 goes to 7. 7 stays put. What happens to 7? 7 goes to 2. 2 stays put. What happens to 2? 2 goes to 4. 4 goes to 8. What happens to 8? 8 stays put. 8 goes to 3. What happens to 3? 3 goes to 5. 5 stays put. What happens to 5? 5 goes to 1. 1 stays put. And that's all the numbers, so we're good. So these two multiplied together gives you a 1, 2, 3, 4, 5, 6, 7, 8 cycle. Again, 9 goes to 7, 7 goes to 2, 8 stays put, 8 goes to 3 goes to 5, 5 goes to 1, so close it off. Similarly, you can multiply those. What happens? I don't see a 1, so I'll start with 2. 2 goes to 4, and then 4 goes to 8. So what happens to 8? 8 goes to 7. 8 stays put, 8 goes to 7. What happens to 7? 7 goes to 2, 2 stays put, so I close it off. All right, now we'll start with the next number. How about 4? 4 is from smallest to biggest. 4 goes to 6, 6 stays put. What happens to 6? 6 goes to 23, 23 stays put. What happens to 23? 23 goes to 7, 7 goes to 4. So 23 goes to 4. What am I missing? I have 2, 4, 6, I have 23, I have 7, and I have them all. Okay, so you can try multiplying the following permutations. You might want to, or in your teams or by yourself. So you might want to just pause this and work on it for a little bit. When you come back, I'll walk you through the answers. All right, good. You've unpaused it, you've worked these out. It's really good if you work these out. So how about this first one? 1 stays put for the first one, and then 1 goes to 2. So I'm going to go to 2. And then 2 goes to 4. 4 stays put, so 2 goes to 4. 4 goes to 7. 7 goes to 1, so we close it off. 5 stays put. 5 goes to 7. So 5 goes to 7 there. 7 goes to 8. 8 stays put, so 7 goes to 8. 8 goes to 2, and 2 goes to 5. So it goes back there. All right. For the next one, 2 is the smallest number, so I'll say 2 stays put, and then 2 goes to 21. 21 goes to 3, and 3 stays put. What happens to 3? 3 goes to 10, 10 stays put. What happens to 10? 10 goes to 4, 4 stays put. What happens to 4? 4 goes to 7, 7 stays put. What happens to 7? 7 goes to 21, 21 goes to 34, so then I get 34. What happens to 34? 34 stays put, and then I go to 6. What happens to 6? 6 stays put, and 6 goes to 2, and then that's everything. Similarly, 1 goes to 2. Oh, well, look, these two are disjoint. So there's actually going to be no mixing. So 1's going to go to 2, 2's going to go to 5, 5's going to go to 1, because that doesn't mess with 1, 2, 5. And similarly, this one doesn't mess with 3, 7, 9, 8. So that's the symbols we can get. How about this one? What happens? 1 goes to 5, 5 goes to 4, so 1, 4. 4 goes to 1, 1 goes to 4. Wait, 4 goes to 1, 1 goes to 2, sorry, so 4 goes to 2. What happens to 2? 2 goes to 4, 4 goes to 1, so we close it off. What happens to 5? 5 goes to 2, 2 goes to 5, so 5 stays put. So sometimes we'll write it as just a 1 cycle, but we normally just omit it. How about this? What happens to 1? 1 goes to 4, 4 goes to 5, so 1 ultimately goes to 5. Then 5 goes to 8, 8 goes to 1, so we close it off. What happens to 2? 2 goes to 5, 5 goes to 6, so I get 2, 6. What happens to 6? 6 goes to 1, 1 goes to 2. That closes it off. Then 3 goes to 6, 6 goes to 7, 7 goes to 2, 2 goes to 3. 4 goes to 7, 7 goes to 8, so I get 4, 8. 8 goes to 3, 3 goes to 4. And we're done with that. And lastly, 1 goes to 2, 2 stays put, and then 2 goes to 6, so 1 goes to 6. What happens to 6? 6 stays put, 6 stays put, 6 goes to 4. What happens to 4? 4 goes to 1, 1 goes to 5, 5 stays put. What happens to 5? 5 stays put. 5 goes to 4. 4 goes to 9. 9. What happens to 9? 9 stays put. 9 goes to 1. Stays put. That's it. That's it. Thanks a lot.